In this particular demo, we are going to take a look at the OCI Vault service in action. So let's get started. To bring up the OCI Vault service, click on the service navigation menu on the left hand side, click on identity and security, and Vault is right here. So the first thing you need to decide is you need to choose a compartment. We have been using the sandbox compartment, and you need to create a vault. So let's hit vault here. Compartment sandbox is fine, and we could call this as my first vault. I'll say vault 1, and right here I can choose to make it a virtual private vault. I'm going with a standard or a default vault. The difference is if I choose the virtual private vault, this gets me a dedicated partition on the HSM, and the pricing is more expensive, and we discussed this in the theory lesson. So I'm okay with creating a standard vault, and vaults would take a few seconds and it would get created, and once the vault is created, we'll come and create master encryption keys, and then what we'll do is we'll take some plain text, and then we'll show how encryption and decryption works, and we will use the OCI CLI to run this operation. And if you head over to the OCI CLI documentation, you can see the details. We are going to use encrypt and decrypt operation, and you can see the syntax here on the encrypt operation and similar syntax on decrypt. So as soon as the vault is created, we'll go and we'll run this particular demo. Alright, looks like the vault is created, and the first thing I want to show here is it says virtual private. No, it's a standard vault or a default vault, and then you see these two endpoints. Now one thing to keep in mind is the vault service is a public service. You can see these two URLs, and if you hover over those, it shows you that the cryptographic endpoint is used for cryptographic operations. As you can guess, what are these? Encrypt, decrypt, generate data encryption keys, etc. Management endpoint are for management operations, so things like create, update, list operations, right? So these two endpoints, and we'll be using the cryptographic endpoint as part of our demo. So let's go ahead and create a master encryption key, and we'll name this key as master encryption key 1, and right here you can see that there are two kind of protection modes. One is HSM and the other is software. When you choose HSM, your keys are stored on an HSM and cannot be exported from that HSM. All cryptographic operations involving the key also happen on the HSM. In case of software, that's not the case. The keys are stored on a server and can be exported from the server to perform cryptographic operations on the client instead of on the server. So that's the big difference, and you pay more for HSM. So we'll choose software here, and I can change the key shape to 56 bits is good. And I'll just hit and create a key here. This again should take a few seconds, and the master encryption key would be created. Alright, so looks like the vault and the master encryption key are created. As you can see here, the master encryption key, I would need the OSID from the master encryption key, and then I would need the cryptographic endpoint from the vault to run the encryption and decryption operation. So let me just bring up Cloud Shell here a little bigger, and what we are going to do is we are going to convert this plain text into ciphertext, and then we are going to look at we take the ciphertext and we'll convert it, decrypt it back to plain text. Now one thing to keep in mind is we are doing a base 64 encoding here, and if you go on to the OCI CLI, you can see the usage listed here, and it says we need to the plain text we are using in the example needs to be converted to base 64, needs to be base 64 encoded. If you don't do that, you will not get the right result. And if you just want to see what we just did with plain text here, echo this thing, and you can see that it's basically the plain text which we just did a base 64 in encoding. And if I just show you really quickly, if I decode this, you can see that it's back the same text we use, the plain text we use. So we took the plain text, did a base64 encoding of that, and that got me with this operation. And then if I use the base64 decoding, I could see the same information. So we have done no kind of encryption or decryption operation right now. Now I have the script here just to make it quicker. Instead of typing the whole big script, let me just run it and I'll explain to you what's going on here. So if I come to the Cloud Shell and I just paste this, what I'm trying to do here is I'm running the CLI and the KMS crypto operation, and specifically I'm doing encryption here. Plain text is the plain text which says let's look at the OCI KMS demo base64 encoded, and the two pieces of information I need. One is the key ID, that's the OSID for the master encryption key, and then I need the cryptographic endpoint. And now what this is going to do is it's going to run the encryption, and it's successful and return this value. And if I do the echo the encrypted text value, encrypted text, I can see that this is it returns me this ciphertext. Now I need to get this ciphertext out from this sort of the JSON result which the CLI returns, and I put it in the encrypted text string. So to do that, I have a quick script here, and let me just if I do that, you can see if I echo the ciphertext, you can see that this is my ciphertext. Now if we started with this kind of plain text, with the encryption operation we have converted into this ciphertext. Now if anyone tries to sniff on it, they cannot find it useful, because looking at this kind of a gibberish text, they cannot figure out that it basically is the same plain text. And that's the power of encryption. That's how you would encrypt. Now we need to do decryption, because on the other side, if somebody wants to read that information, they would need to do the decryption operation. So again, I have the text here. Let me just paste it here and clear the screen, or actually let the screen be there. And if I paste it here, you can see that I'm running the decryption operation here, and looks like there is some error. Let me just go back and make sure that I'm using the right keys. It looks like I'm not using the right key, so that's why it gave me an error. So let me just paste it here really quickly. You have to make sure that you're using the right key version, the right key OSID, and this operation should work fine. Copy that. And as you can see, this worked perfectly fine. And if I see my decrypted text now, you can see that it returns again a JSON, and there is the plain text here. But this is not the plain text which says let's look at the OCI KMS demo. Why is that? Well, this is base64 encoded, so we need to decode it. We should be able to see that text, original text. So we pick this particular plain text which is base64 encoded. So we pick that, put that in the base64 encoded plain text, and now we just simply need to change it back to decode it, and this should give us our original text. And you can see here that we can get the original text here, right? So just to recap, we took a plain text, we did base64 encoding on that, and then we ran the encryption operation and we encrypted that data, and that gives us this ciphertext. And basically we collected that ciphertext, and this is that ciphertext. Now if anybody gets hold of it, they cannot figure out that it means this plain text. Let's look at this OCI KMS demo. So this is the ciphertext. We took that ciphertext and we ran a decrypt operation on that, and it's similar to encryption. The decrypt operation is OCI KMS decrypt, and the two pieces of information we need is the key ID OSID. We had given a wrong one here, so it didn't work. And we need the endpoint, the cryptographic endpoint. And then of course we need the ciphertext here. Like for encryption, we needed the plain text. Now we need the ciphertext, and all this is base64 encoded. and so it returns this big JSON, and this is the plain text it returns, again base64 encoded. So running this particular command, we took out we ran a query, and we took out this portion of the string from that query, and then we decoded that particular string, and then we get the original plain text back. So this is a very quick demo of how encryption and decryption can work using the OCI KMS CLI. I hope you found this demo useful. Welcome to this lesson where we will look at the various OCI services and their integration with the Vault service. As we saw in the intro lesson on OCI Vault, there are many OCI services which integrate with a Vault for encryption and decryption, and you can see the list here. It's object storage, as you can imagine, storage services like object storage, file storage, block storage, streaming for stream pools, container engine for Kubernetes, and autonomous container database. And this list is going to expand in the future, so you should always check the public documentation to see which services are supported or support OCI Vault for encryption and decryption. As you can imagine, all these services are regional, and so it kind of shows this region, and they're using the Vault in the same region. Now there is this concept of Oracle managed keys and customer managed keys, and we'll talk about these in a little bit detail, and we'll look into a demo very soon. But when you're using Oracle managed keys, right, what you're doing is, as we discussed in the previous slide, you whether it's block volumes, your file systems, object storage buckets, your OKE container engine secrets, autonomous container database, stream pools, they are all by default encrypted using Oracle managed keys. So in Oracle, the encryption for data at rest is on by default. You cannot turn it off, right? So that's important to keep in mind. It's if you don't choose anything, it's done by us. Now, Oracle managed keys, what it means is we have an Oracle managed vault which has a master encryption key which provides a data encryption key to the respective services to encrypt the data. So it's the same process as we looked into the OCI Vault intro lesson. It's the same process. You have a master encryption key that generates a data encryption key, is kind of this envelope encryption, and that data encryption key is used to encrypt the data, and that's sent to the respective services. So by default, the data at rest is encrypted. Now you can see this kind of this is a snapshot from the object storage bucket. You can see that there are checkbox, kind of a radio button between using Oracle managed keys and customer managed keys. So you have that option. So what does exactly this look like, right? And how do we do this in action? We'll see a quick demo. Now, if you decide not to use Oracle managed keys for whatever security reasons, you could use your own customer managed keys. Now, remember, keep in mind, customer managed key is not the same as bring your own key, right? Bring your own key is when you're bringing your own keys. You're importing keys into the Vault service. Customer managed keys means the keys are generated within the Vault service, but it's your own key. It's not the key which Oracle generates in its own. Like a customer also has its own vault where we generate and keep these master encryption keys. In this case, customer managed means it's your vault, it's your keys, and you are responsible for the life cycle of the keys. Now you can use your own keys, and the process is exactly the same as we discussed in previously, right? It's the same exact process, and we'll quickly look into this in a demo, right? So let's look at it from a kind of a visual perspective, because this is important concept and you need to understand. So right here is shown OCI Vault service backed by an HSM hardware security module with kind of the level 3 FIPS 140-2 level 3 certification. And within the OCI Vault service, you can have authentication and authorization to decide, who has access to the vault, and if they have access to the vault, what kind of policies and permissions they have, right? So that's being shown here. Now let us say you want to encrypt some data. you are putting that data in object storage and you want to encrypt that data. And let's look at how this process works. And again, keep in mind the same process holds true for Oracle managed keys as well as customer managed keys. There's absolutely no difference whatsoever, right? The process is exactly the same. It's just that who manages the keys and who controls that the keys, which is different. So for in this example, you have object storage bucket where you want to put some plain text data. Let's say it's a log file. You want to put that in an object storage bucket. So what the object storage does is it requests a plain text data encryption key and a copy of the key encrypted under the master encryption key from the Vault service. So as you can see here, it's generating a data key request. Now the Vault service returns the data key, which is the plain text here, right? So this data key is kind of the plain text, but it also returns an encrypted data key. So you can see this yellow border here. It's envelope encryption. So this data key is encrypted here. Now what the object storage service does is it takes the data key to encrypt data, this particular data key, which is plain text. So it is used to encrypt the data, and then it removes it from the memory as soon as it's used. So this service has no access to this plain text data key. It uses it and then it discards it. It throws that away because it should not be storing the plain text data key. And this encrypted data and the encrypted data key are stored in a bucket, right? So the data is here, which is now encrypted, and this encrypted data key are stored in a bucket. So even if somebody, let's say, gets access to these artifacts, both the data and the encrypted data key, they cannot make any sense of it, right? Because the data key itself is encrypted, so it's kind of protected, and your data is also encrypted. It's kind of ciphertext, right? So this is how the encryption process works. In the reverse, suppose you want to decrypt this data, what happens is the data is stored in the bucket and the encrypted data key is stored in the bucket along with all the metadata. So the object storage service follows kind of a similar process, a series of steps. So first thing it does is it sends the encrypted data key to the vault, because object storage service doesn't know what that data key has, right? So it cannot, because it's all kind of ciphertext. So it sends that to the vault. Now the vault service has a master encryption key. So it looks at that, it looks at the encrypted data key, it removes the envelope encryption, and then it sends the data key from the vault, right? And this is the plain text data key. And now the object storage service can take this plain text data key and it could decrypt the data, the ciphertext, back to plain text. And then once it is done, it removes the data key from memory as soon as that process is over, right? So this is how it works end to end. Keep in mind, at any point, the object storage service, or for that matter, any other service which integrates with Vault, has no access to the plain text data key. So it's always protected. It uses it for encryption and decryption, but throws away after it's used from throws away from memory after it's being used. And the Vault service has the master key, so it can generate an encrypted data key, or it can take a encrypted data key and send a plain text data key back to the service, right? So this is how it works, and similar process is followed for file systems and block volumes, etc. But this kind of, I just wanted to represent and show how it works with OCI object storage. So let me jump over to the console and show you how this whole thing works in the console. All right, so I'm in the console here and I can see that I have a couple of vaults created, and these vaults have a few keys created, right? I created my first key, my second key, and some other keys, right? If I jump over to storage and I bring up a bucket here, I can see there are a couple of buckets which are created. Let's go ahead and create another bucket. So by default, it picks a name, which is fine. It picks a default storage tier, that's fine. And right here, you can see encryption. So it says Oracle Managed Keys and Customer Managed Keys. If I do nothing, if I just say encrypt using Oracle Managed Keys, a bucket is created, and we are using a key which is controlled by Oracle, has its own vault. Master encryption key generates a data encryption key to do the encryption, as we saw in the previous slide. But let's say we don't want to do it. Let's go ahead and create another bucket. So I'll choose this particular bucket and I'll say this is a test bucket, and I'll encrypt using customer managed keys. I'll pick this particular vault, and I'll pick this particular key, and I'll click create here. And now it's as simple as that, and my bucket is encrypted with a customer managed key which I control. So this is hopefully a quick lesson and a quick demo on how you could use customer managed keys for encryption and decryption, and how these various services, storage, database services, etc., integrate with the OCI Vault service for encryption and decryption. I hope you found this lesson useful. Thanks for watching. Welcome to this lesson on OCI Vault secrets. As you recall from the intro lesson on OCI Vault, we discussed the key characteristic of the service as vaults, keys, and secrets. And until now, we have not really dealt with secrets. So let's look into that as the first thing. But before we do that, what are these things called secrets? Well, secrets can be anything that you want to control access to: API keys, passwords, certificates, database, admin passwords, etc. More services means there is going to be more authentication and there are going to be more secrets. And using a secret manager is the foremost security best practice, right? We have all taken this kind of a route where humans tend to take insecure shortcuts, right? Hard coding the secrets in source code, container images, configuration files. Credentials are we are all guilty of, sharing credentials via email, Slack, and shared folders in plain text. We all have done it at some point or other. So the whole idea is that's kind of not a security best practice. So we need to avoid that. And OCI has a feature where you can store these secrets. Until now, as we discussed, we talked about keys, and we talked about vaults, and we talked about the whole idea of a dedicated HSM partition, the private vault, and just the standard vault, which is kind of a shared HSM partition, right? And as we saw earlier, these keys and secrets are protected at rest with the encryption guarantees of a FIPS 140-2 security level 3 security certification compliant HSM hardware security modules that backs the vault where the secret and keys are created and stored, right? So it's kind of gives you that capability to store the secrets in the vault service rather than storing it in your configuration files or sharing it in plain text with other users. So this is the kind of the second part of the service we haven't discussed until now. Now you can store information, as we discussed, like public keys or passwords as secrets in the vault, and this is a more secure way to store and retrieve them. You can create secrets by using the console, CLI, API, whichever method you prefer. And secrets like keys can be rotated to reduce impact in case the secret is exposed or compromised. And we'll jump into the console and take a look at this. But creating a secret is as simple as going on the OCI Vault service. I'm using the console right now and providing a kind of a key value pair. So I'm saying, my secret here is database password, and I basically give what the contents are, and I have to specify the encryption key, the master encryption key, right? And that is used to kind of change this plain text password, or in case of secret, into the ciphertext, right? And the service stores that, and then you can retrieve it when you need it or your application needs it. There are a couple of things which you need to keep in mind as you're working with secret, which are called secrets rules. So there are kind of two rules. The first one is called the reuse rule, and the whole idea is that it prevents the reuse of secret contents across different versions of a secret. See, what happens is the secret itself, is stored in kind of a ciphertext. However, while in application memory, a secret could be compromised. So, preventing the reuse of secret contents by having multiple secret versions serves to limit the scope of affected resources in the event of a security breach involving that particular stored credential, right? So that's the whole idea of creating a rule around secret reuse rule. And you can see here the configuration, it says enforce on deleted secret versions, right? So if you feel something has been compromised, you could delete that particular version. And there's also something called secret expiry rule, and this restricts how long the secret contents of a particular secret version can remain in use. This rule can also block the retrieval of secret contents for a secret or secret version past the configured expiration date. So, configuring an expiring rule to specify a time range for how long a secret version can exist also helps limit the impact of a potential security breach. And you can see here I can specify this value. I think it goes from 1 to 365 days. So the standard is I think anywhere from 1 to 90 days. And I can also block content retrieval on expiry. So once this version expires, I cannot retrieve it. So let me quickly jump onto the console and show you how easy it is to work with these secrets inside the OCI Vault service. Alright, so I'm in the OCI Vault service, and we saw we have a couple of vaults here. I'll click on this Vault 1, and right here you can see the master encryption keys we created a bunch of these keys. If I click on secrets, you can see I've created a password, secret around database password. Let me go ahead and create another password here. So this one I'll call, let's say this is my MySQL DB password. This is my password for MySQL, right? And now I need to choose my key here. So I would choose this master encryption key, and it gives me an option to either put the secret value in plain text, or I could even put this in a base 64 encoded value. I could do that, but for this particular demo I'm just going to use something straightforward in kind of plain text, and I'll say this is my MySQL password, and I can also see the base 64 conversion, right? Not doing that, and I'll create this secret here, and it's as simple as that, right? My secret gets created here, and then what I can do is if I click on the secret here, I can create a secret version. This is the other the one which already exists. So you can see that the latest version is this one, says 1. I can create a secret version here, right? And I could say, this is my DB password version 2, and I can create this secret version here, right? And now you will see that this version is the one which is current, and the version 1 becomes the previous one, right? So this is as simple as creating a new version here, and if I suspect that the previous version has been compromised, I can just change and create a new secret version here. Now I can also create these rules here, right? If I click on edit rules, you can see that I have rules created here. Secret reuse rule, I can enforce it on deleted secret version, or I could decide not to enforce it. And then I can set expiry rule, where I say that the version expires every 10 days, and if it expires, then block content retrieval on expiry. And I can create these rules here. So this is it's quite simple to use secrets within OCI Vault. And how do you use these secrets? Well, your application, right now I'm just showing kind of a console example just for to show it quickly, but in real life what your applications would do is they would access the Vault service and the secrets either using the CLI or the SDK. Probably the SDK is kind of an application, and they would retrieve the secrets from the Vault service, and then they would use the secret within their application, removing the need to actually store the secret in a plain text format, right? They're accessing it through the Vault. So this is how it would work, and there's several examples in our documentation site which walk you through on how this works in action. So hopefully this was a quick demo on secrets, and you found this lesson and the demo useful. Thank you for watching.
Hello and welcome to this demo on automating secret generation and rotation with the OCI Secret Management Service. In this demo, we'll explore the importance of managing secrets securely and efficiently, and how the OCI Secret Management Service helps automate this process. Before we get into OCI Secret Management on the console, let's talk about why automation is important. Secret automation is critical for preventing unauthorized access to sensitive data like passwords, API keys, and encryption keys. By regularly rotating secrets, the potential impact of compromised credentials is reduced. This significantly reduces the risk of data breaches even if secrets are leaked. Automating tasks such as secret generation and rotation also saves valuable time for human resources. This improves overall efficiency and reduces the possibility of human error when handling sensitive data. Many compliance regulations mandate regular secret rotation, and automation ensures compliance with these regulations. reducing the possibility of non-compliance penalties. So instead of managing secret generation and rotation within your application scripts, you can generate and rotate secrets automatically. It supports automatic secret generation for passwords, SSH keys, and random bytes so that you can use it in multiple use cases. In addition, whether created automatically or manually, secrets are stored in an encrypted vault using HSM for added security. Automatic rotation enables you to set rotation schedules such as monthly rotations or to rotate them immediately. This feature is integrated with the Autonomous Database and Functions services, allowing for the easy rotation of secrets used in Autonomous Database or function code. Your applications start using the new secret immediately. OCI Functions allows you to easily rotate any credential while executing code. It also includes notification capabilities to keep you informed of successful rotations. Additionally, detailed audit logs are kept to make compliance audits simple. Now let us walk through the process of generating a secret in OCI on the console. First, I navigate to the OCI vault in Identity and Security. I have a vault pre-created in our root compartment. Here we will first create a master encryption key to keep our secret encrypted. Provide the name master encryption key, secret demo, protection mode, HSM, and select the symmetric key type. Click Create Key. And once our key is created, we go ahead and create a secret. Demo secret and select our encryption key. Now here you can select automatic or manual secret generation. If you select automatic generation, you have the option to generate passwords, SSH keys, or random bytes, so you can select any generation type as per your use case. We will select the passphrase, default password, and length, which we will set to 15, and here you can define the format for secret generation. I will use the default format for now. Next, you can specify the secret rotation rules, such as which application from the Autonomous Database or OCI function will use the secret, and we must provide the OCID for that resource. Then you can define a rotation interval to update the secret periodically. We will not add any applications for this demo. We will try to retrieve secrets from an application running on a compute instance so that we can verify different generation types easily. Click Create Secret and our secret will be created. Let's try to access the secret content from a compute instance. I will SSH into the compute instance. And I have a script that can access the secret content. Here we will update our secret OCID and save the script. This is the same script that we used in the previous demo, so the process to allow this instance to access secrets was already discussed in our previous demo. Now I will execute the script so you can see the automatically generated password or secret content. As you can see, the secret length is 15 characters, same what we defined it while creating the secret. If I go back and create a new secret version with the same settings, the new version will be created and will be set to current. If I run this script again, the content from the new version will be displayed. You can even change the length and generation type. If your application requires SSH keys, set the generation type to SSH keys and update. Then you create new version with SSH setting, and once new version is created, you can go back to terminal and confirm the secret content. And you will notice that the secret content is now an SSH key pair that is public and private key pairs. Similarly, you can verify random bytes. So to wrap up, you can use automatic secret generation and automatic secret rotation, eliminating the need for updating multiple scripts and reducing human effort and errors in managing sensitive credentials. I hope you found this demo helpful. Thanks for watching. Hello and welcome. In this demo on OCI Vault and Instance Principle, we will explore how these features can be used together to securely store and retrieve sensitive information, such as passwords or other secrets. Let us consider a scenario where you have a program running on a compute instance that requires access to an external service. To do so, the program requires a username and password. One common option is to hardcode the password into the program, and we already know that hardcoding the password into the program is not a good idea. So here we have a solution. We will utilize a unique feature of OCI called the instance principle, where this feature allows the compute instance itself to be authorized to make API calls to other services without requiring a password. So by using the instance principle, we do not need a password to retrieve a secret in this scenario. Then, to securely store the sensitive information, we will utilize OCI Vault. Vault is a fully managed service that allows you to store and manage secrets, keys, and certificates. It provides a centralized location for managing and auditing sensitive information. And by using a policy, we can restrict a compute instance to only access or retrieve a specific secret from a vault. By combining all three features, instance principle, vaults, and policies, we have much better way for a program to access sensitive information. So let's go ahead and deploy the solution using these features. To make this demo work, we will follow a step-by-step process. Please note that for the purpose of this demo, I have already created a compartment and VCN with a public subnet. Here are the steps we will follow. First, create a vault with a key and a secret to store our sensitive data. Then, create a compute instance in a public subnet. Then, create a policy using dynamic group to control access to the secret. After that, on compute instance, we will install the required Linux packages and set up the environment. And at last, to retrieve the secret, we will download and execute the Python script on the compute instance. Alright, let's get started with the demo. The first thing we need to do is to check IAM policies set for this demo. We go to the identity and security, click policies, and check all the required policies are in place. Now we move ahead with step 1, where we will create a vault in our working compartment. To do this, we go to the navigation menu, select Identity and Security and click on Vault. Then we will click on Create Vault, select our working compartment and name it as Demo Vault 01. Once we have done that, we will click Create and we are done. Next, we need to create a key that will be used to encrypt our secret. So we click on Create Key, select our working compartment, select Protection Mode HSM and name it as Demo Master Encryption Key MSK01. Once the key is enabled, we move ahead and create our secret. We select a secret from the resources, click Create Secret, then we select our working compartment. We will name it as Demo Secret 01 and we will select a key that we have created, Demo MSK01. And we will select plain text and enter our secret content. For example, I will just enter my secret password and click Create. Once the secret state is active, we go ahead and copy the OSID which is required later to retrieve the secret. So we have successfully created a vault, key and a secret to store our sensitive data. Now the next step is to provision a compute instance. We go to the navigation menu, click Compute and click Instance. Now we will create instance, provide a name Demo Secret VM01, ensure the working compartment, let the shape and image be default, select the VCN and select the public subnet, provide public key for SSH or we will generate it over here and then click Create. Now that we have created a compute instance to run a Python script, next we need to create a dynamic group and a policy that will allow compute instance to access the secret. To create dynamic group, we go to the navigation menu, select Identity and Security. Under Identity, we click Dynamic Group. Click Create Dynamic Group. Provide the name Demo Secret DG01. We can add the description DG for Secret VM01. Click on Using Rule Builder. We will copy the OCID ID of compartment that we want to add. I will add the compartment OCID ID, which indicate all the instances in this compartment is a part of dynamic group. Click Create. Now we have created a dynamic group. We need to add a policy for that. So we go back to the policy, select our policy for this demo, and then we'll edit the policy statement and add another statement where we will add a policy to allow dynamic group demo secret DG01 to read the secret family in a compartment sandbox vault where target.secret.name is equal to the secret name, that is demo secret01. Here we have allowed a dynamic group of instances in a compartment to read secret in a scope of sandbox vault compartment, where we have limited access to a specific secret called demo secret01. We save the changes and done. And now our next step is to SSH into the compute instance and install the required packages on the compute instance. And then we will execute a Python script to retrieve the secret created in the OCI vault. For that, we go to the Cloud Shell and wait to get a prompt. And first we need to upload the private key for VM and change the permission. So to change the permission, chmod 400 demo secret VM private.key, which I have uploaded now, and then we will try to SSH. We hit SSH-I, private key name, space OPC at public IP address of compute instance. And now we got a terminal for compute instance. We will install the required packages. The first package that I will install is related to the developer release. I just copy paste the command, enter. Next, we will install Python packages. So to save the time on the demo, I have already created a Python script that will retrieve a secret from the OCI Vault service. Now I download the script from the GitHub repository by hitting wget space the link. You can also access this repository and get this Python script. We will open it in an editor, that is nano space getsecret.py, enter. Now you can see we have the script that use the OCI Python SDK to authenticate instance and retrieve the secret from the OCI vault using the instance principal authentication method. If you scan the script, we need to provide secret OCID. So we'll copy the secret OCID ID and paste it over here. We save the file Ctrl O and to exit Ctrl X. So now we have edited the file. We'll execute the script by hitting the command python space getsecret.py. And here we have a secret, indicating that Python script running on the compute instance has access to the secret created in the OCI vault. And that's it. You now know how to use the OCI instance principal and vault to retrieve a secret. This can be useful if you need to securely store sensitive information such as database password or API keys in a vault and retrieve it from your application. Thank you for your time and happy learning. Hello and welcome to this lesson on Dedicated Key Management Service. In this lesson, we will see how you can ensure that your keys are stored and managed in a dedicated HSM partition using dedicated KMS. So let's see how this service offers you ownership of your cryptographic keys and the hardware security module. We will start by understanding what is OCI dedicated KMS. It is a customer controlled HSM, which means it provides us with dedicated HSM partition and you can claim the ownership for that dedicated partition. So basically, hardware security module or HSM is a PCI card and has many partitions in it, and each partition has a root key to define ownership of that partition. So far, with the private vault offering, the root key was managed or maintained by OCI. It helps us to replicate partitions, take backups, and migrate to other HSM providers as required. But if you want full control over keys as well as HSM and don't want Oracle admins to control partitions, then you can opt for dedicated KMS. With this service, you get full control over HSM partitions. And in one HSM cluster, you have 3 partitions which are owned by you by claiming the root keys of those partitions during the partition claiming process. This gives you complete access to the dedicated partition and the ability to manage your own root key. You also have complete control over key generation, storage, and usage, allowing you to improve the security and autonomy of data encryption process. The partitions provided with dedicated KMS are FIPS Level 3 certified, offering a greater level of security for key management. This level of security and control is essential for organizations that handle sensitive data and need to follow strict compliance regulations. It enables you to use HSM native interface with protocols such as PKCS 11. It is the industry standard interface for performing cryptographic operations that are end-to-end encrypted from your applications to the HSM without the need for OCI APIs or KMS modules. As mentioned earlier, by default you get 3 HSM partitions per OCI region. And even if you have ownership of HSM partitions, OCI will continue to cover their provisioning, maintenance and management. Next, as you can see in this architecture diagram, you can create an HSM cluster, get 3 HSM partitions and then set up root certificates to have ownership of those partitions. Once the ownership claiming process is completed, you can use the PKCS 11 interface from your compute instance, which is running your application, to securely manage and store cryptographic keys within the HSM partitions. And as you can see, no OCI APIs or KMS interface are used to have access to the keys. This adds seamless integration and minimize latency, and it will also improve the overall performance. So next, here we will look at the basic workflow for creating an HSM cluster and getting ownership of the partitions of that cluster. First, you must request a limit increase for the HSM cluster resource, which is initially set to 0 for all tenancies. Then you create an HSM cluster, which can be done using the KMS APIs, CLI, or using the OCI console. After creating a cluster, it goes into the initialization required state. In this state, you need to initialize the cluster. That means for claiming the ownership of HSM partitions, you first download the HSM certificate signing request, that is CSR, and then you sign it and upload the signed certificate. Once the signed certificate have been uploaded, you need to install and configure client utilities, which include user management utilities and key management utilities. This enables you to activate the HSM cluster. After activation, you will be able to locate credentials for the pre-crypto officer. It is a temporary, less privileged user on the HSM partitions that has never been activated. You must update or change this user password in order to gain complete control over the HSM partitions. Once activated, the user will become the crypto officer of your HSM partition. Finally, you will need to install the PKCS 11 interface provider. So this is the complete workflow for setting up an HSM cluster and ensuring that all credentials and utilities are available, as well as ensuring that you have ownership of partitions in the HSM cluster. So to conclude, in this lesson, we got to know what is dedicated key management service, what it offers, and how to configure it to have ownership of provided HSM partition. In the next lesson, we will see some use cases and difference between private vault and dedicated KMS. That will help you understand when we should opt or select the dedicated KMS offering. Thanks for your time and see you in the next lesson. Hello and welcome to this lesson on external KMS. In this lesson, we will discuss how to use OCI External Key Management Service to encrypt data in OCI using encryption keys that are managed by a third-party key management system hosted outside OCI. We will explore the benefits of using external KMS and see how it allows you to fulfill security, control, and regulatory requirements. We will divide this lesson into two parts. The first will explain what external KMS is, and the second will go over the onboarding process and when to use external KMS. So let's get started. As we know, OCI KMS offers various options for storing and managing encryption keys. First, we have the OCI Virtual Vault with a multi-tenant HSM partition where you can create and manage your keys. In this service, customer has control over keys and HSM partitions is shared with multiple customers and managed by OCI. Next, you have the private vault offering where you get a single tenant HSM partition that gives slightly more control. Here, the root key of the HSM partition is owned by OCI. You also have the option of a dedicated KMS to get full ownership of the HSM partition. Then there is the option to bring your own keys. This is where you import your own keys into the OCI vault. It gives you even more control since you, as a customer, create and manage the keys. Now let us talk about the hold your own key concept. This is for customers with regulatory requirements regarding where their encryption keys are stored. With this option, customers can create, manage, and store their keys either on their own premises or with third-party service outside OCI. This gives them complete control over their keys and ensures they stay compliant with regulations. This is what OCI External KMS offers. So with OCI External KMS, you have complete control over your encryption keys, including where they are located and how they are distributed. This perfectly aligns with the hold your own keys principle. It ensures a smooth and secure transition for customers who want to retain control over their keys while using OCI services. This service offers centralized key management, simplifying encryption key handling process while maintaining full visibility and control. OCI KMS will never directly interact with your third-party key management system, and it cannot create, view, manage, or delete your keys. Instead, it only interacts with key references, improving security measures. And you have full authority to manage access to your keys and can revoke access at any time. This ensures that your keys remain secure and under your control at all time. Next, we look at this reference architecture to understand how the external KMS works. On the left hand side, we have all OCI services such as storage, ADB, file storage, and Exadata, as well as any other application or service that can connect to an OCI KMS can use or leverage an external KMS. So this is how it works. When a key operation request is initiated, OCI KMS communicates with the third-party key management system. In this case, OCI KMS acts as a proxy rather than storing the master encryption key itself. So any request made to OCI KMS is sent to a third-party key management system, either external or on-premises, using a private endpoint. Now, this is where the actual encryption or decryption happens. From the customer's point of view, the master encryption key is never stored in OCI KMS, and this is how external KMS get easily integrated into the OCI KMS workflow. Next, we will see the detailed workflow for encryption and decryption operations. First, OCI application or service sends request for encryption or decryption. Then, the request is forwarded by an external KMS to the third-party key management system, which is typically deployed on the customer's premises, such as Thales. The third-party management system then encrypts or decrypts the data as requested and returns it to the OCI external KMS. Finally, OCI external KMS forwards the response from Thales back to the OCI application or service that initiated the request. So this is a seamless workflow with external KMS offering where customers' keys are kept on-prem and protecting data at OCI. So to conclude, we got to know how external KMS perfectly aligns with the hold your own key principle. This service also allows you to create, manage and store keys on-prem or with third-party service outside of OCI. We also saw how OCI services can integrate with an external KMS to perform cryptographic operations. In the next lesson, we will look at the onboarding process and when to use external KMS. Thanks for your time. See you in the next lesson. Hello and welcome. In this module, we will introduce you to OCI or Organization Management, which helps customers to securely scale their OCI environment. Using Organization Management, you can add tenancies, apply governance, and centrally manage cost across your organization. So let us dive deep to understand OCI Organization Management. For example, your company or your organization has a single tenancy and large universal credit model subscription. But due to the compliance requirement, you need to have multiple tenancies that are physically segregated and use different identity provider for each environment. Here, compartment segregation alone may not be sufficient, and creating new pay-as-you-go account or new UCM contracts may not be feasible or desirable. So this is where OCI Organization Management comes in. With Organization Management, you can add multiple tenancies to your organization and have them consume primary funded subscription. This means that you can create an isolated tenancy to build workloads without having to create a new order. And you can do this by yourself on console. But that's not all. Organization Management allows you to manage multiple tenancies centrally. You can invite and create child tenancies, view and map subscription, and create and attach governance rules to tenancies in your organization. So there are two types of tenancies involved for mapping and using subscription in Organization Management. First, we have parent tenancy, which is associated with primary funded subscription. With the parent tenancy, you can extend your organization by adding new tenancies and managing subscription. It also allows you to centrally manage governance and cost across all tenancies in your organization. Then we have child tenancies, which can be created as an entirely new tenancy, or we can invite existing tenancies to join the parent tenancy to become a part of same organization. Child tenancies consume the subscription within the organization, which enables better utilization of credits. As a parent in OCI Organization Management, you can set governance rules for tenancies within your organization. This means that you can enforce limits on the services a tenancy can use or limit the number of resources within a service. You can also set an allowed list of regions as permitted by your compliance standards. Additionally, you can create tag namespaces or define default tags to ensure consistent tagging. Now let us talk about the benefits of using OCI Organization Management to handle multiple tenancies. First, customer with strict data isolation requirement can use it to isolate data and restrict resources across their tenancies. Second, it makes billing much easier as all the tenancies within your organization are built through the same account or single account. Using organization management, you can enforce and govern resources for specific child tenancies or the entire organization. This can help you to maintain compliance and ensure consistency across your tenancies. Finally, central cost management helps you to perform cost analysis and generate cost and usage reports. You can also receive alerts through budgets, which can help you to stay on top of your spending and avoid unexpected expenses. So to wrap up, using OCI organization management, you can manage multiple tenancies centrally, attach governance rules to each tenancy, and enforce rules to restrict access to services and regions. Thank you for your time. See you in the next lesson. Welcome back. We will see how to set up OCI organization management on console to create or invite child tenancies, apply governance rules, and manage multiple tenancies. To do this, we go to the navigation menu, click on governance and administration, and then click on organization management. Over here, you can manage tenancies. As a parent tenancy, you can invite or create new child tenancies in your organization. The newly created child tenancy consumes parent tenancy subscription. Then there is a MAP subscription, where an organization can have multiple subscriptions that are managed by the parent tenancy. For example, an organization has one subscription A, but later child tenancy joins the organization with its own subscription B. The parent tenancy can then use subscription mapping to link subscription B to other tenancies in the organization. As a result, an organization's subscription can be mapped to any tenancy in the organization. Using invite option, we can see invitation, accept them, reject them, or remove invited tenancies from the organization. And by using governance rules, we can create rules for a tenancy and attach them to it. The governance rules are created by the parent tenancy and targeted at one or more child tenancies. When rules are enforced, users within child tenancies are not permitted to modify the rules. Like they get a message on quota policy page that the resource was created and locked by the parent tenancy using governance rules. So now we can start by creating a new child tenancy. For that, we go to tenancy and click create new tenancy. If you check the workflow, first we provide tenancy details, and then we can attach governance rules to the new tenancy and create it. You can attach rules to the new tenancy during the creation process, or you can come back later and attach rules. For now, I'll first create the rules and then add them to a new tenancy. To do that, I'll go back to the governance rule page and click create rules. First, I will provide the name. I'll call it as rule 01 for compute and select type as quota policy. Then under rule configuration, we provide description and quota policy statement. Description will be compute quota policy, and then I will add a quota policy for compute. This policy limits the core of VM standard 2 and bare metal standard 2 compute series to 10 in all compartments of child tenancy. We will not add this rule to any child tenancy for now, so we go ahead and click create rules. Similarly, you can create rules for regions and tags as well. I have already created few for demo purpose. Now we will go ahead and create a new tenancy. Click tenancies and click create new tenancy. Provide the name. I'll call it as test city child tenancy. Select home region. Provide an email address where you will receive tenancy details. I'll enter my email address, confirm the email address, and click next. Then you will select the rules that you need to enforce on new tenancy related to quota, region or tags. And then click Next. Review the details and then click on Create Tenancy. I am not creating a tenancy now due to the limitation of this account, but this is the process. You will see new tenancy created here and details will be sent to the administrator's email address. In similar way, you can invite a tenancy by providing tenancy OSID and applying rules. If the tenancy administrator accepts your invitation, the tenancy will become a part of your organization. I hope you found this demo useful on organization management. Thanks for your time.
Hello and welcome. In this lesson, we are going to discuss OCI Azure Interconnect. So let's get started. In 2019, Oracle and Microsoft announced a partnership to enhance cloud interoperability by connecting Oracle Cloud Infrastructure and Microsoft Azure by a secure, low latency and high throughput network, which is known as the OCI Azure Interconnect. So OCI Azure Interconnect can be established with a one-time setup, eliminating the requirement for an intermediary network provider. The cross-cloud direct connection also helps you migrate to the cloud or build cloud-native applications by using the best of OCI and Microsoft Azure. Now, as it is a private connectivity between Oracle Cloud Infrastructure and Microsoft Azure, you get consistent network performance, which is around 2 millisecond latency. The interconnect also enables joint customers to take advantage of a unified identity and access management platform. So what you can do is you can set up single sign-on between Microsoft Azure and OCI for your Oracle applications such as PeopleSoft and eBusiness Suite. Now, having a federated single sign-on makes the integration seamless and allows users to authenticate only once to access multiple applications without signing in separately to access each application. And you also get a secure intercloud connection that bypasses the public internet. So as you can see in this slide, OCI has the fastest growing network of global data centers with 41 cloud regions available, and there are 9 more that are planned. And you also see that there are 12 Azure Interconnect regions. For example, this Ashburn, you have OCI Azure Interconnect region. Now in this architecture, there is a virtual network in a Microsoft Azure region, which is connected to a virtual cloud network in an OCI region using a private interconnection composed of Azure Express Route and OCI Fast Connect. Now on the OCI side, the Fast Connect virtual circuit terminates at a dynamic routing gateway, which is attached to the virtual cloud network. On the Microsoft Azure side, the Express Route connection ends at a virtual network gateway, which is attached to a virtual network. So traffic from Azure to OCI is routed through the virtual network gateway in Microsoft Azure to the dynamic routing gateway in OCI. Now, the point here is that in both the directions, the traffic never leaves the private network. Now, let's look at some of the common use cases of OCI Azure Interconnect. Now, on the right, you can see some of the supported deployment options. For example, resources in the virtual network can run a .NET application and that can access an Oracle database that runs on the database service resources in the VCN. Similarly, you can see that you can also have custom cloud native applications running on Azure using Oracle Autonomous Database on the OCI side. Now let's talk about the building blocks of OCI Azure Interconnect. Now in this slide, we have listed the comparable networking components involved in each side of the connection. Now there are also some prerequisites when you configure the OCI Azure interconnect, you must have a virtual network with subnets and virtual network gateway. And on the OCI side, you must have a VCN with subnets and an attached dynamic routing gateway. Now, if we look at the virtual network component, on the OCI side, there is a virtual cloud network, and on the Azure side, there is virtual network. Now, from a virtual circuit standpoint, in OCI, there is Fast Connect virtual circuit. On the Azure side, there is Express Route circuit. When it comes to gateway, on the OCI side, there is dynamic routing gateway, and on the Azure side, there is virtual network gateway. Similarly, for the routing, there are route tables in OCI and Microsoft Azure. And from a security standpoint, in OCI, you can configure security lists as well as network security groups. And on the Azure side, you have network security groups. So the intention of this slide was just to compare the networking components that are involved in each side of the connection. So let's look at some of the partnership benefits. So you can innovate using the best combination of Oracle's and Microsoft's cloud services based on their features, performance, and pricing. So in a way, you can combine capabilities of both the cloud vendors. Now, this partnership also gives you a highly optimized, secure, and unified cross-cloud experience. So you can use the best of services from Oracle Cloud Infrastructure and Microsoft Azure. And the best part is you can continue to leverage any existing investment in Oracle and Microsoft technologies. All right, this marks the end of this lesson where we have seen how by using Oracle Fast Connect and Azure Express Route, customers can seamlessly build a private interconnection between their OCI and Microsoft Azure environments. Thanks for watching.
Hello and welcome. I am Samvit, and in this demonstration, myself and Sergio will show you how you can set up a direct interconnection between Microsoft Azure and Oracle Cloud Infrastructure. So let's get started. So as you can see, I am inside the Azure portal, and before I start provisioning resources, let me first show you this architecture. I will be taking care of the resources on the Microsoft Azure side, and then I will hand it over to Sergio, who will then provision resources on the OCI side and configure or set up the interconnection. So let's get started. On the Azure side, the first thing that I'm going to create is a resource group. So let me click on resource group. Let me click on create. Now this resource group is very similar to a compartment in Oracle Cloud Infrastructure. It's basically a grouping of related resources. So I'll give my resource group a name and I will call it to OCI resource group. The region I'll keep as East US. I'll click on review and create. I'll wait for the validation to pass and then click on create. So whatever resources I'll be provisioning in this demonstration, on the Azure side, I will be using this particular resource group. So now let me go ahead and create a virtual network. So I'll click on virtual networks. I'll click on create. I'll select the subscription, Azure subscription 1. And now I'll select the resource group, to OCI resource group. I'll provide the name for my virtual network, which is again going to be to OCI VNet. I'll select the region as East to West. I'll click on next. I'll not enable any of the security features here. I'll click on next. Now here you see that this is going to be the IP address space or the CIDR range for the virtual network. And I also see there is a default subnet. So let me first edit it and make the name as 2OCI subnet. I'll click on save. So this is the first change that I made. Now I also need to add a subnet, because at a later stage I will be provisioning a virtual network gateway, right? So for that, in Azure you have a requirement that you require a specific subnet. So under the subnet details, you see there is a subnet template. So instead of the default, I will use virtual network gateway. So the moment you select virtual network gateway, it automatically provides the name of the subnet as gateway subnet, and it provides or configures the starting address as this 10.0.1.0, and the subnet size is /27. This is what is recommended by Azure. I'll click on add. Remember, I have created two subnets. The first subnet is where I will launch a virtual machine subsequently. The second subnet is where I will create a virtual network gateway. All right. So everything looks good. Let me click on review and create. So the validation is passed. Now I can click on create. Yeah, so the deployment is now complete. So let me go to the resource. So this is the virtual network that I created, right? And you can see the address space here, 10.0.0.0/16. And what you can also see is there are two subnets. One is 2OCI subnet and the other one is gateway subnet. Let me return back. Now the next step is we need to create a virtual network gateway. So I can just type here virtual network gateways. So let me create a virtual network gateway. Now if you look at this architecture, on the Azure side you require a virtual network gateway, and on the OCI side you require a dynamic routing gateway. So currently we are working on the Azure resource provisioning, so I will create this particular resource, virtual network gateway. So to create a virtual network gateway you need to provide subscription. Now you need to give it a name. You can just call it 2OCI virtual network gateway, VNG. The region is east to west. The gateway type has to be express route, because you see here it's basically fast connect plus express route. So I am basically specifying the gateway type as express route. The SKU is standard. I am okay with that. Virtual network I have already created, so I will just select 2OCI VNet, and you will see that it automatically selects gateway subnet. Now I also need to create a public IP address, so I will just give it a name. So this is the name. I am okay with basic SKU, and then I will click on review and create. So currently it is running validation. Validation is passed. Now let me click on create. Now in the meantime, what I will do is I will also start provisioning a virtual machine that Sergio is going to use later in the demonstration for showing you how the ping works after that interconnect is configured. So let me go back and let me provision a virtual machine first. So I'll just type virtual machine. So let me create a virtual machine. So I need to select a subscription. I need to provide the resource group. I'll be providing that same resource group that I created. I'll give my virtual machine a name, 2OCI VM. I'm okay with east to west region, and here I will just provide zone 2. And you can provide any zone, right? So that will not make a difference. I'm okay with other settings. Image is Ubuntu server, and I will provide the username as Azure user, and I will provide the password. All right. So you also see that we are allowing SSH port 22, which basically means that from internet you will be able to SSH to this particular machine, right? Because this is a test scenario. I'll go to next disks, keep everything default, next networking, ensure that the virtual network that we created is selected, and the subnet here I'm going to select 2OCI subnet. Rest everything remains the same. Let me go ahead and click on review and create. Okay, so the validation has passed. Let me click on create. So currently there are two deployments that is in progress. The first one is virtual network gateway, this particular, and the second one is for the virtual machine. As you can see, the virtual network gateway as well as the virtual machine got deployed successfully. The virtual machine took around 2 to 3 minutes, whereas this virtual network gateway, it took close to 40 minutes. So let's quickly look at what got created. First, I will go to the virtual machines and I'll click on 2OCI VM. So under properties, you can see that now there is a public IP address and private IP address assigned to the virtual machine. Alright, so that was the first thing, and the second thing that got created was the virtual network gateway. So if I click on 2OCI VNG, I can basically see that this is the SKU, this is the gateway type, which is ExpressRoute. Alright, so now the next thing is to create an ExpressRoute circuit. So let's quickly do that. Let me search ExpressRoute. So here it is under services. I'll click on ExpressRoute circuits and I'll click on create ExpressRoute circuit. I'll select the subscription. I'll select the resource group 2OCI RG. The region is East US and I will basically give it a name 2OCI ExpressRoute. I'll click on next configuration. The port type is provider, it's not direct, and the provider is going to be, let me search for Oracle. So it's going to be Oracle Cloud Fast Connect. The peering location will be Washington DC because that's the closest one to US East, and I will select the bandwidth as 50 Mbps. I'm okay with standard SKU. The billing model is metered. So let me go ahead and click on review and create. Now you can see that the validation has passed. Let me click on create. And in some time we'll have the ExpressRoute circuit provisioned for us. You see that the deployment is now complete. So if I go to the resource, you can see that this is my ExpressRoute circuit and the provider is Oracle Cloud Fast Connect. So as of now, the circuit status is enabled, but the provider status is not provisioned. So I basically need to provide this service key to Sergio, who is then going to complete the direct interconnect setup between Oracle Cloud Infrastructure and Microsoft Azure. So let me hand it over to Sergio.
Thank you, Sambit. Much appreciated. Now let's go ahead and configure the OCI side. As you saw, Sambit created all of this, all of these resources, and now he provided me with the circuit ID, and now I need to provision this on the OCI side. So let's go ahead and get started. He started with the resource group. So it's appropriate that I start with building the compartment. I don't have a compartment right now. So you find that under identity and security. This is the compartment that we're using. And we are going to give it a name. And that name is going to be Fast Connect to ExpressRoute. So first we click create the compartment. Then this is the name. The description will be demo from OCI to Azure. And this is the parent compartment, which is the root compartment. It's as easy as that. And it takes no time to provision. So we now have our compartment. If I do a refresh, you should see it. And here it is. So this is the compartment that we're going to be using. And as the next step, we are going to be building the virtual cloud network. So this is the equivalence that we have. on Azure, we have the VNet. On the OCI side, we have the virtual cloud network. So let's go ahead and create that. And we'll do that by clicking here under networking. And then as you can see, I need to select the compartment that we just created. So we should see it here. If I do a refresh, it's going to show. And here it is. So we have two options. This allows you to create everything manually. And we have the VCN wizard. So let's go ahead and select the VCN wizard. Out of the two options, we're not looking for a VPN right now. We are looking to create virtual cloud network with internet connectivity. And I'm not going to be needing these resources, but it doesn't hurt to have them. I can delete them later on. So let's go ahead and get started. Now let's give it a name. So I know that Sambit used to OCI VNet. So we are going to be using something similar. We're used to Azure VCN. And as you can see, I am in the right compartment. Now, I don't want to overlap with Sambit. So I'm going to change this to a 172.16. I don't need IPv6, but I do need my subnets. And I'm only going to be using the public one, but this is the wizard, so it creates these resources for me. So this is a /24 and obviously cannot overlap with the one above. So a /1 will do. And as easy as that, we will have our subnet. Goes through the process of creating it, and it does this really fast. The one that takes a little bit longer is actually the one that we're not using. We can go ahead and delete it, but I can leave it there. One thing that I need to do, and I'm going to go ahead and view my VCN, because we are going to be using ping as the test once we complete the exercise. So I need to go into my security list and enable ICMP for echo. So let's go ahead and add a rule. And it's CIDR, so the source is going to be, gonna make it very specific to what Sambit used. I'm going to be using ICMP, and it's 8. This is echo. And I can enter this in the description. So there it goes. Now we can make sure that our security list will be able to ping with echo. These two are for troubleshooting purposes. So we have our VCN. Now we need to create the equivalent to the virtual network gateway, which is our dynamic routing gateway. So let's go ahead and create that. And you find the dynamic routing gateway also in the main menu. Go to networking, and under customer connectivity, you will see the dynamic routing gateway. And this will not take as long as the virtual network gateway from Azure. This is done and is provisioned really fast, and you don't need a subnet for it. You need to attach the VCN. So let's go ahead and create it. The name is going to be very similar to what Sambit used, to Azure DRG, and we are in the right compartment. So let's go ahead and create the dynamic routing gateway. And it's in the process of being built, but as you can see, I don't have a virtual cloud network attached. I can go ahead and attach it right now while it's being provisioned. I stand corrected. I need this to be lit. And there it is. Create the attachment. So I'm going to name it likewise. Attachment. Select my VCN. And there we go. So now it is attached. So what is next? Once you have this attached, then you need to create a route that will take you to the other end. But I can also it doesn't have to follow any order. So first, I'm going to go and create that route that use the DRG that I have. So it's going to be here on my route tables. And on my default route, I'm going to add a route rule that goes to the dynamic routing gateway. And whenever I'm going to 10.0.0.0/16, I'm going to go to Assure. So now I have my route rule. I can go back into networking, select customer connectivity, select my dynamic routing gateway. And where it is, here it is. And now that I'm here, I can go ahead and work with my virtual attachments. As you can see, I don't have one, it's 0. So I can go ahead and create the Fast Connect circuit that goes directly into Assure. So here I'm going to go ahead and create the Fast Connect. And I'm going to be selecting the partner type. So by typing Microsoft Azure Express Route, and here it is. So now I click Next, and I'm going to give it a name. So this name is going to be to Azure Fast Connect. So here we go. And it's a private virtual circuit. That means that our private resources on OCI are going to be connecting to the private resources on the Assured side. So here I do have a dynamic routing gateway. Here, what bandwidth I'm going to be using. So I'm going to go with the lowest one that we have, 1 gigabit per second. It doesn't mean that I'm going to be using that bandwidth because I understand that Summit created one that is smaller. So we are going to be constrained to that, the other end. Now here is where we install the partner service key. So you might recall Summit provided me with the service key, which is this one right here. Let me bring it to the screen. And all I have to do is copy and paste it here. And there we go. We have the service key. Now the BGP numbering is for the router that connects both networks. So, or both cloud providers. So here we're going to use /30. This is for the partner part. Now the OCI part is going to be the .1. And now the secondary one is going to be /6 for the partner. And we'll use /5 for ourselves. And that's all we need. And here comes the beauty of it. You will see this go up as soon as it provisions. And it doesn't take as long as it does with the Assured side. So while we're doing this, as soon as we get this up, we still need to establish the connection on the Assured side. So the connectivity begins on the Assured side and it ends on the Assured side. So once this is up, and you will see the status of being up, we still need to enable routing on it. But in the meantime, while this is being created, let's go ahead and build a compute instance. And I don't have a single compute instance here. So let me go ahead and create one. So you click create the instance, give it a name, VM. So I'm still in the right compartment. And I can select any availability domain that I want. This, I'm going to select availability domain 2, just because I want. And I'll stay with every single default value that is being offered to me. Now, on the networking side, here I'm going to select the correct VCN, the correct subnet. It's going to assign an IPv4 address for me. Now, the SSH keys, I'm going to generate a private key. So this is going to be secure. And there it is. It's downloaded. So once I have this key, I'm going and I create this virtual machine, I'm going to be able to log in. So let's go ahead and create this. And as you can see, the compute instance is up and running. This is the public IP address. This is the private IP address. And now let's go ahead and check the dynamic routing gateway. So we go to networking, and actually we are going to be checking the Fast Connect. So if we go to Fast Connect, we can see that it's loading from the Fast Connect to ExpressRoute compartment. And as you can see, it's being provisioned. It's in the upstate, and we're working with IPv4. So if I click on it, you will see more details of the connection. So now let's go ahead and log in into the compute instance. And right now, even though it's up, I will not be able to ping the virtual machine at the assured side because the connection on the assured side has not been established. It was waiting for the circuit to come up. Let's go ahead and open PuTTY. And here it is. So I'm going to be loading this up, and I have the IP address in memory. So there it is. I need the key that I downloaded. So let's go ahead and search for it. I'm going to browse for it, and it is on my downloading folder. So now I should be able to connect, and here I am. It opened in my other window. So if I go ahead and ping 10.0.0.4, is going to fail. So right now, I'm going to hand it over back to Sambit, and he'll complete the connection. Then I'll come back and retype this command again, and you will see the low latency and the connection completely established all the way through. So see you in a little bit, and here you go, Sambit. Thank you.
All right, thanks, Sergio. And let's look at the ExpressRoute circuit now. So if I click on the ExpressRoute circuits, so you can see that the provider status is now provisioned, right? So what does it mean? Let me try to ping the OCI instance now using the private IP address. So you'll see that the ping is still not working. Why? Because we haven't yet created the connection. So let me create the connection. So basically, we want to create a secure connection to our virtual network by using ExpressRoute. So let's do that. Let me click on connections. Let me click on create connection. I'll select the subscription. I'll also select the resource group. I'll select the connection type as ExpressRoute. I will give it a name to OCI connection. I am okay with the East US region. Next, I will go to settings. I'll select the virtual network gateway, and I'll also select the ExpressRoute circuit. I'll keep everything as the default. I'll click on review and create. So waiting for the final validation to complete. So the validation is now passed. I'll click on create. All right, so the deployment is now complete. And if I go to the resource, I'll see that this connection is now, you see the status is succeeded. Now let me try to again perform a ping. So currently I'm inside the Azure VM, and this time, as you can see, I am able to ping the OCI virtual machine instance using private IP address. So now over to Sergio, and he will try to ping Azure virtual machine private IP address from inside the OCI virtual machine instance.
Thank you, Sambit. I see that you already completed the test. Now let's do it bidirectional. Now I'm going to ping the other way around. So I'm going to open my session, and I'm already logged in. So all I have to do is ping which is your IP address of your computer instance or your virtual machine. And here we go. 2.25 under 3 milliseconds ping time. So this completes the connection. I hope that you have enjoyed it, and thank you very much for paying attention. Thank you very much. Bye.
Hello everyone, welcome to this lesson on Introduction to Oracle Database at Azure. I'm Rashmi, your instructor for this lesson. We'll begin the course with a small introduction to multi-cloud, what do enterprises multi-cloud strategy looks like, and the possible reasons for preferring multi-cloud deployment. As we progress in this lesson, we'll learn about Oracle's multi-cloud strategy and the latest service offerings. Let's begin then. I believe all would agree that cloud adoption has become the new normal for a vast majority of enterprises. They're able to exploit the enormous benefits that cloud can deliver with speed. They're able to modernize infrastructure, harness performance and the complete automation it provides, flexible elasticity options, agile development platform, vast range of emerging cloud-native technology support, CI/CD automation, and many more. With this growing cloud adoption among customers, multi-cloud strategy has become ubiquitous. According to the survey, 98% of enterprises are using or plan to use 2 or more clouds. There are multiple reasons for the consideration. One cloud environment may provide services that best suits to the specific workload needs of the enterprise. Another cloud environment may provide greater performance benefits or meet the security or regional compliance requirement. Enterprises also adopt multi-cloud for better business continuity and disaster recovery solutions. They can avoid vendor lock-in and have a wider choice in terms of service selection as per suitability. Enterprise-wide survey revealed that cost optimization and data residency as the top 2 benefits, followed by business agility and innovation. These are the key drivers for multi-cloud adoption. Let's talk about one of the multi-cloud strategy in the context of this course. Oracle and Azure has been into strategic partnership for quite some time to provide cloud interoperability that allowed customers to build and deploy cross-cloud application across Azure and OCI environment. The partnership added first capability in 2019 to establish a private low latency interconnect between Azure and OCI that enabled faster and secured communication between the deployments in OCI and Azure. The next capability is called Oracle Database Service for Azure. It relieved customers from manual configuration of the private interconnect by providing a Oracle managed network link between OCI and Azure. It simplified provisioning of OCI database services, giving users an Azure-like portal experience while allowing users the benefit to monitor the database's metrics and events directly from Azure. Oracle managed the network link to provide customers with a consistent network performance even if the workload transfer increased. The latest addition to this partnership is Oracle Database at Azure, which we are going to learn about in this course. Oracle Database at Azure. This is an Oracle Cloud Database service that runs right inside the Microsoft Azure data center. It provides customer simple and secure access to Oracle Cloud Database services within their chosen Azure deployment region without getting into the complexity of managing networking between the cloud vendors. It was made generally available in 2023. Let's get some more overview on this service. Oracle Database at Azure service runs inside Microsoft Azure Data Center and uses Azure networking. The entire Oracle Cloud Database Service infrastructure resides in Azure Data Center, while it is managed by expert team of Oracle Cloud Infrastructure Operations team. It is natively integrated with various Microsoft Azure services. This provides a seamless user experience when configuring and using the different Azure services with OCI Oracle Database. Since much of the complexity associated with the configuration is greatly simplified. There is no requirement of setting up private interconnect between Microsoft Azure and OCI, since the service itself resides within the Azure data center and uses Azure network. This is very beneficial in terms of strategic deployment, as customers can experience microseconds network latency between the endpoints while receiving a high performance database environment. Currently, it supports Oracle Exadata Database Service on dedicated infrastructure, which will be expanded to other OCI database services. With this kind of service, you get a robust database environment that is highly performing, provides greater capacity for scalability, defense in depth, and helps customer at an SLAs of critical business applications by providing an environment that is always on. Any issues that might arise in your deployment are coordinated and addressed by the respective cloud providers accountable for the detected fault. For example, any issues related to the database and OCI tenancy will be resolved by Oracle support team, and for issues on Azure VNet, Bastions, VMs, or Azure monitoring service, this will be resolved by Azure support team. Let's check at a high level of the different phases that you would pass through while working with the Oracle Database at Azure service. You begin with purchase of the subscription from Oracle and setting up the billing account. Then you provision the database, resources, and the service. You are then ready to configure your application to connect to the database and work on the remaining deployment. As you continue using the service, you can monitor the different resource metrics using the Azure monitoring services and analyze those logs using Azure Log Analytics. Let's discuss about the task responsibilities that would be held by the customer and Oracle while using Oracle Database at Azure service. Oracle Cloud Operations team is entirely responsible for managing the Exadata database infrastructure and the VM cluster resources that are provisioned in Microsoft Azure Data Center. Oracle is responsible for maintaining the service software and infrastructure by applying updates as they are released. And for any issues arising from the OCI database service and the resources would be addressed by Oracle support. You have to raise a support ticket for them to investigate and provide resolution. And as Azure customers, you have to do right sizing based on your workload needs and provision the Exadata database infrastructure and VM cluster in OCI pod within Azure Data Center. You have to provision the database in Exadata database service, apply the database and system updates, take advantage of the cloud automation to maintain and manage the database. You have to load data, establish the connectivity, and support development on your database. As customer, you monitor the database and infrastructure metrics and events, and also analyze those logs using the Microsoft Azure provided native services. We see here why multi-cloud is beneficial and how it is being set as a successful deployment strategy across several enterprises. A single cloud environment may not be a one-size-fits-all solution for enterprises with discrete workload needs, and there are other factors that come into play while choosing a multi-cloud deployment strategy. Oracle and Microsoft together understood those complexities involved while working with customers that use both OCI and Microsoft Azure services for building and deploying their applications. Their partnership has reaped benefits for the customer with the release of multiple multi-cloud capabilities, and Oracle Database at Azure is one such service that has enabled customers to configure application with OCI database services within Azure Data Center, just like any other native Azure services. They get the same level of database performance, security, scalability, availability as they would get with OCI Oracle Database services. We'll discuss the architecture and some other details about the service as we proceed. I hope this briefing was helpful. Thanks for watching.
Let's take a look at the physical data center level architecture. Each OCI region has 1 or 3 availability domains, also known as ADs. Each AD can have multiple child data center sites acting as an extension of the OCI AD. The child sites of a region are an integral part of OCI. For Oracle Database at Azure, we built child sites inside Azure Data Center. We refer to the child sites in Azure Data Center as OCI pods. We connect OCI pods to a distinct OCI region that is the closest in terms of physical distance and network distance. Oracle Database at Azure as well as their key dependencies, are hosted entirely in the OCI pods inside the Azure Data Center. OCI pods have the same underlying infrastructure as any other OCI region or OCI data center, same Gen 2 network stack, off-box virtualization, RDMA network to power the Exadata service and autonomous database service. The service stack in the OCI pods in Azure Data Center are also the same as we have at any other OCI region. Same OCI virtual networking stack, OCI Exadata service, OCI autonomous service, and so on and so forth. All the security updates, security patching, deployments to OCI pods are all performed the same way. The security controls, operation control are all done the same way as we do for OCI regions. So essentially, the OCI pods in Azure Data Center act as an extension of OCI region. When customer creates Oracle database at Azure DB cluster in a subnet in customer's VNet, behind the scenes, what we do is we create a private IP address in the designated subnet in customer's Azure VNet, and then create a necessary VNIX in private VCN of the database instance in OCI. And then we create a virtual mapping between the NIC and the IP address in Azure VNet and the VNIC in OCI VCN. A key highlight of the OCI pod architecture is that we have partnered very closely with Microsoft to create a direct private network connectivity between OCI pod and Azure Data Center and the Azure network in the same data center. So when an app in Azure VNet connects to the database service using a private IP address assigned to the NIC of the Exadata instance or the Exadata cluster, if you will, the Azure Virtual Networking Service routes the packets through the direct local link to the edge gateway located in the OCI pod, where the OCI Virtual Networking Stack receives the packets and then forwards that directly to the Exadata service instance in the OCI pod. The direct private network link plays a key role in delivering ultra-low latency between the clients inside Azure Network and Oracle database instances in the OCI pod, while also ensuring the network traffic doesn't leave Azure Data Center. Let's take a closer look at what happens when a customer creates an Exadata instance. Customer typically goes to an Azure portal, creates an Exadata instance, and creates DB clusters and databases inside the DB clusters. The API calls emanating from the portal first hit the Azure Resource Manager, which then sends API calls to Oracle database at Azure Resource Provider, which can be hosted anywhere, but in this case, it's actually hosted in OCI region. The resource provider performs the appropriate translation. It also performs the identity validation, authentication, and authorization. And then finally, it invokes OCI control plane, which then creates and manages the Exadata instance. Note that the customer can just use identity in Azure to invoke the API calls or use the portal. And behind the scenes, OCI will use identity federation to perform the authentication and authorization for the API calls. Thank you for joining us today.
Hello everyone, welcome back. In this lesson, we are going to discuss about how you can provision the different resources so that you can actually start using the databases with Oracle Database at Azure Service. As we learned earlier, Oracle Database at Azure at present supports OCI Exadata Database Service. As far as provisioning of the resources is concerned, the process remains same as in OCI, except the environment where you provision changes. Here you first provision the Exadata infrastructure, followed by Exadata VM cluster in OCI pod within Azure Data Center that is plugged into the Azure VNet. Next, you use this cluster environment to provision container and pluggable databases in Oracle Cloud Infrastructure. Operation within the services has to be performed across either in Azure portal or in OCI portal. Let's understand which activities are performed in each of these interfaces. You use the Azure portal to provision Exciter infrastructure and Exciter VM cluster, apart from the onboarding process of Oracle Database at Azure service. Provisioning of these two resources can also be performed using the Azure provided APIs, SDKs, and Terraform scripts. Management and maintenance of these two resources is also done from the Azure portal. You can scale up the servers and OCPUs. Software and infrastructure maintenance updates received from OCI are updated on Exciter infrastructure using Azure portal. Infrastructure and database metrics and events are also monitored from Azure portal using the Azure services. Activities that are performed entirely in OCI portal are very database specific. You provision version specific Oracle database homes in the Exciter VM cluster that was provisioned in Azure. Using those Oracle database homes, you provision container and pluggable databases to be connected to your application. Database management activities like automatic backup configuration, data guard, this can be enabled from OCI portal. You can also update the grid infrastructure, database, and system updates. You can migrate to the provisioned Oracle database using the conventional tools or the automated tools like Zero Downtime Migration or the OCI Data Migration Service. Let's discuss on the provisioning aspects of the resources we discussed. Provisioning of the Oracle Exciter infrastructure is initiated from the Oracle Database at Azure Blade in the resources section of Azure portal. The user performing the provision must be a member of Oracle Database at Azure infrastructure admin group. You will see different tabs and you have to fill values for the various fields required for provisioning Exciter infrastructure. You provide Azure subscription name and Azure resource group name. Then provide the instance details like instance name, region, and the Azure availability zone. Oracle Cloud account name is the one you had linked during the onboarding step. From the drop-down, under Configuration tab, select the available Exciter model. You then select the number of database servers and the storage servers with minimum of 2 and 3 respectively, which can be scaled up to the limit supported by the model. The values for the OCPUs and storage fields will get auto-populated based on the number of selected servers. You specify the maintenance method, which can be rolling or non-rolling, and the maintenance schedule like month of the quarter, week of the month, day of the week, hour of the day, and notification lead time and the email list. Next, you have to provision Oracle Exciter VM cluster on the Exciter infrastructure you had provisioned. The user performing the operation must be a member of Oracle Database at Azure VM cluster admin group. As a prerequisite, you must delegate the client and backup subnets in Azure VNet that is going to be assigned to the VM cluster during provisioning. Again, start from the Oracle Database at Azure Blade in the resources section of Azure portal and select the Oracle Exciter VM cluster tab. Provide the Azure subscription name and the Azure resource group name. Specify a unique name for the instance in the subscription and provide the region name same as the one where the Exciter infrastructure was created. You should fill the cluster name same as the name field. Choose a license type, that is license included or BYOL. Select the Oracle Exciter infrastructure which you provisioned, the grid infrastructure version. Select the required time zone and fill the SSH public key field. Then you fill the value for the configuration tab like compute count, that is the number of cluster nodes, the shape, the OCPU per VM, memory per VM, and the local storage per VM. Slide the bar for the amount of usable Exciter storage based on the Oracle Exciter infrastructure you had selected earlier. There are fields like use Exciter sparse snapshots, use local backups, usable storage distribution, which are optional but you must set now, else it cannot be set once the VM cluster has been created. Under Networking tab, provide the delegated subnet details. Likewise, proceed with the next set of tabs which are self-explanatory until you click the Create button to initiate creation of the VM cluster. Our final provisioning step will conclude with the provisioning of the databases. This is entirely executed from Oracle Cloud infrastructure. You must ensure the operating user is a member of Oracle Database at Azure, CDB and PDB admin group in Azure. If you had performed the identity federation during the onboarding step, then the Azure group is replicated into OCI and the policies are defined for the group in OCI. That would give them the required privileges to perform the database administration task. Without identity federation, you have to provide the required authorization or privileges to the OCI user who is going to perform the database administration task. You can directly navigate to OCI console from the Oracle Exadata VM cluster overview page in Azure portal by clicking on the Go to OCI link. Once you are in OCI console, you shall first create Oracle Database Home for the supported database version, followed by provisioning of the databases in those Oracle homes. Once the databases are available, perform the required configuration to enable your application to establish connection with the databases. Just to wrap up on this lesson, the process of provisioning of OCI Exadata database service in Oracle Database at Azure service follows the same sequence of steps as you would do while provisioning the Exadata database on a dedicated infrastructure in OCI. What differs here is the environment where you provision the resources and the network delegation part. You delegate client and backup subnets in Azure to be used for the service. You provision only the Exadata infrastructure and Oracle Exadata VM cluster in Azure portal, which is co-located in Azure Data Center. The provisioning of the databases occur in Oracle Cloud Infrastructure, which will be used by the application that reside in Azure Data Center. I hope this was helpful. Thanks for watching.
Hello. We will first start our provisioning with the Oracle database at Azure Resources on the Azure portal. Here we can provision an Exadata infrastructure as well as the Exadata VM cluster. So let us go to the Azure portal. Here we go to select Azure Oracle database at Azure page, where we select the Oracle database at Azure Exadata deployment. As you can see, there's already 2 infrastructures created, but we will take you through the provisioning screens for the Exadata infrastructure and also for the Exadata VM clusters, where you can see already 4 Exadata infrastructures has been created. So first thing we will need to deploy is an Exadata infrastructure. These are the physical machines and the infrastructure that needs to be deployed. So we go to the create of the Exadata infrastructure. Here we go to the basic information. So the first thing that we need to enter is, of course, the subscription, which is automatically selected as a subscription where you have purchased this private offer. Next thing that we need to choose is a resource group. So we will take the resource group that we created for the infrastructure here. We will give the infrastructure a name. At this stage, we will call it Demo Infra, and we select the region where we want to deploy. At the time of the recording, the solution was already available in 3 different regions. For this demo purpose, we will choose the US East region. For each region where we are deploying this, multiple availability zones are available. For the US East region, we have Zone 1 and Zone 2, where we select Zone 1. The basic information screen will also show you the Oracle account name, which is basically the Oracle tenant, the OCI tenant information. Next step is to choose the configuration. Currently, we support X9M-2 model of the Oracle Exadata database service. Other models will be added at a later stage. We can here select the number of database servers and the number of storage servers. The minimum number of database servers is 2, and the maximum that you can select is 32 database servers for one infrastructure. The number of storage servers is 3. That's the minimum. The maximum that you can choose is 64. As you can see, while you select how many storage servers and database servers you want to deploy in this infrastructure, the number of OCPU or the storage will automatically go up. For this demo, we will only select the minimum values. Next step on the provisioning is the maintenance preferences. Here you can choose a maintenance method for the infrastructure. You can either choose for a rolling or a non-rolling maintenance method. These are the security patches that we make available and install every 3 months, right? Every quarter. As for the maintenance schedule, you can select no preference. That means that we will do the scheduling of the maintenance ourselves, and you do not have a preference on when this will happen. Since it's a rolling method, there should be no impact for your business. However, if you do have a preference on the schedule, you can specify a schedule here. For each quarter, you can select which month you want to deploy this in. For each month, you can select the week of the month you want to deploy this in, the day of the week, and the hour of the day. Of course, you can also make sure that you get a notification ahead of time. And here you can select how much time ahead of time you want to receive this notification, as well as to which email this notification could be sent. In this case, it will take my name. And you can add, of course, additional values. So for first quarter, we will take February. For the second quarter, we will take May. For the third quarter, we will take August. And the fourth quarter, we will take January. The week of the month, in this case, we will select week 1. And the day of the week, let's say a Monday. Time, we'll do it during the nighttime. Next is the general consent for Oracle Database at Azure. This is a general consent that you use for all services in Azure. Here you have to agree to the terms, and then you can add additional tagging. Once the tagging is finished, you can have the review and create screen, and here you can once again review all of the information that you have entered, and when everything is correct, you can press to create. As mentioned, this will take some time, so we will not finalize this creation. However, we can go to the overview page of one of the infrastructures that we have already created. As you can see, the PM Demo Infra 1 has already been created with the same amount of database servers, storage servers, and here you can see the number of OCPUs that we have in total and how much are still available. This concludes the infrastructure creation. The next step that we will do is provision an Exadata VM cluster. We have already provisioned the infrastructure, so now we go ahead creating a VM cluster. For this, we return to our Azure portal and we go to the Azure Oracle Database at Azure landing page. We select the Exadata VM cluster. As you can see, a number has already been created. So let's go through the creation screens. Again, we will need to start with the basic information. Here we have the subscription where we have purchased the solution or purchased the private offer, and we will also deploy within a resource group. For this resource group, we will select a resource group which I created for my first VM cluster. I will call this cluster VMC1. This is display name of the cluster, and we select the region. We have deployed this on an infrastructure in US East, so here our region should be US East. The third line here is the cluster name. The cluster name is actually a generated name that we give to the cluster for internal purposes. However, you can also name this cluster the same name as the display name above. This to avoid any confusion. So I will call this VMC1. The Exadata infrastructure where we are going to create this on is the PM Demo Infra 1, which was already created previously. For the license type, we can select bring your own license or license included. In this case, we don't have the licenses to cover what we will use on the VM cluster, so we will take a license included option, as well as the time zone and the grid infrastructure version can be selected here. Here you can also choose where you can download SSH public key to connect to your guest OS. You can either generate a key pair or use an existing key stored in Azure or use an existing public key. In this case, we will generate the key pair and we can call it VMC1 keys. The next screen is the configuration. We have selected in our infrastructure 2 database servers. So the minimum is 2, and we have selected 2. We have created the data infrastructure with 2, so we will not change that number. As for the number of OCPU, here the minimum is 2 OCPU virtual machine. As we are creating a cluster, and there's 2 nodes in this cluster, 1 on each database server, the total requested OCPU will be 4. This is a minimum configuration. For the memory per VM, we have a minimum of 30 gigabytes times 2 for the 2 nodes in the cluster. Minimum is 60, as well as the local storage is 60 gigabytes times 2 is 120 gigabytes for the minimum. You can also select how much usable exadata storage you want to use for this cluster, and you can scale this up to the maximum. Of course, if you want to deploy more than one cluster on this infrastructure, and you select the maximum here, you can no longer use any storage for other clusters that you want to create. Here you can also enable sparse snapshotting or to use local backups on the local storage. And by selecting this, of course, you will change the ratio on how the usable storage is divided. In this case, I will not use sparse snapshots and I will not use local backups. The next screen is a networking. For this networking, we need a delegated subnet. We have created a delegated subnet in the RGDM VM cluster 1 VNet. This is the VNet. We have created a delegated subnet in demo VNet 1. To check on how this is created, we go to the networking. So we open another tab on the Azure portal. We go to the VNet. And the subnet information is right here. We have named our subnet that we wanted to delegate to this solution delegated VMC1. As you can see, it is delegated to Oracle Database Network Attachments. To change this or to delegate this, you just go to the subnet information, and here you can select to delegate the delegation. This is what we have done previously, and now this subnet is already delegated. That's why we can see it here in the drop-down menu. In the client subnet, we can find delegated VMC1. The backup CIDR is something that you can determine yourself too. The backup subnet will not be created in Azure, but to avoid any overlap, you can enter the CIDR range here. What you can also choose is whether you want to use custom private DNS or you want to use the default private DNS created by the service. In our case, I will not use a custom DNS, and the host name prefix I will create here is host VMC1 as a prefix. For the diagnostics collection, you need to enable all of the events and the monitoring. And the next screen is, again, the basic or the general consent that you give for the service on Azure, as well as tags that you can add in the next screen. So once all of these details are entered, we go over to the review and create screen to review all of the information that we have entered. And if this is correct, we press the create button. This will take a couple of hours. So let's go to a VM cluster that we have already created to check on all of the details. So once the VM cluster is created, you will see that all this information that we've entered here, as well as the virtual network, the client subnet, which is a delegated subnet, the host name, and the scan information is all available on this overview page. Here we also have a deep link to go to OCI, and this will take us to the OCI portal where we can start creating the databases. Hello. So now we go to the last part of this deployment. And for this, you will see that we will use the deep link on the Azure portal, and this will get us to the Oracle console to create and provision the container databases as well as the pluggable databases. So for that, we will first go to the Azure portal where we have created our cluster. So again, you could go to the service, the Exadata service that we have here. We go to the VM cluster details, and then we select the cluster where we want to create the databases. Here you have a deep link into OCI. If you press this link, you will get to the equivalent page showing the information of the VM cluster in OCI. This is the VM cluster page on OCI, where you can see all of the information that is available on this VM cluster. But here you can also create an Oracle, create container databases. So let's create a database here. Let's call it demo database 1. We will leave the unique name as is. We don't need a unique name for this demo, and we'll select a PDB name. We call it PDB1. Here you can select if you want to use an existing home, or if it's the first database you want to create on this cluster, you select to create a new home, and you can give it a display name. We will enter the sys password here. And we will do it again to confirm it. And the next step would be configuring the database backups. The service offers automatic backup to object storage in OCI that comes actually out of the box with the service. So here you can select the object storage and the retention period on how long those backups for this database you want to keep, as well as the schedule when you want to schedule this backup, schedule the full backup. We will take a full backup at 8 a.m. in the morning and the incremental backups at the same time. We have some additional options that we can show here, like the character sets created for the database, as well as the Oracle SID prefix. But also you can select here the key management for your database. Either you want to use the Oracle managed keys, so Oracle manages the keys for you, or you want to use customer managed keys. And then in this case, you can select a vault where you want to use. This is an OCI vault and the key that you want to use specifically for this database. Once this is done, you can hit create database, and the database creation, CDB and PDB will start to get created. Once this is created, the provisioning is complete, and you will see that the database is available and reachable from your Azure network.
Hello and welcome to this lesson, an introduction to Oracle Cloud VMS Solution. Oracle Cloud VMS Solution, or OCVS, is an integrated solution developed from a partnership between Oracle and VMware by Broadcom. This solution enables you to run VMware Software-Defined Data Center natively hosted under Oracle Cloud Infrastructure. Oracle and VMware have partnered together not just in developing the solution, but also it provides technical support at different tier levels. Now, before I get into the product specifics, let's look into what is a software-defined data center, or we call it as SDDC, and why do you need an SDDC to run your applications? Primarily, there are three building blocks that forms a physical data center. The compute, that means the servers, the storage for storing your data, and the networks, your switching, routing, security, and so on. In most cases, the compute servers will be running a hypervisor or a virtualization platform. That means you can run several virtual machines overriding the limitations of a physical server. SDDC is a concept that extends this virtualization to all other resources in a data center, whether it could be your storage array or it could be your networks. Everything is fully software defined, and it makes it an abstraction layer forming a platform of multiple virtual data centers that are delivered as a service. Resources in SDDC are shared between application workloads. There is no longer a one-to-one dependency to a physical resource. So this grouping together allows you to oversubscribe. That means you can maximize the physical resource usage by several times. SDDC capitalizes on agility, elasticity, and scalability. One of the top advantages of being software defined is automation. And for example, you could be automating the creation of a virtual machine, or it could be automating the creation of a virtual switch. SDDC provides a high degree of flexibility because the workloads now operate independently of the underlying physical infrastructure. And for this reason, you can deliver an SDDC on a flexible mix of private and hybrid clouds like OCVS. Due to the fact there is no interdependency between the apps running on the physical infrastructure, this provides the environment portable and bringing capabilities to seamlessly integrate new applications that makes SDDC a modernized platform. VMware Cloud Foundation, or VCF, is the industry-leading product from VMware by Broadcom, and that incorporates the compute storage networks, delivering a highly reliable and scalable SDDC platform. Oracle Cloud VMware solution is a solution based on VCF, the VMware Cloud Foundation. VCF is an integrated software stack that are deployed on top of bare metal instances under Oracle Cloud Infrastructure. Let's look into the VMware software editions used in the solution. All these software products in VCF together provides a certified and verified architecture for SDDC deployment. The product stack includes vSphere Enterprise Plus. vSphere is a combination of the hypervisor and a management software called vCenter. NSXT Enterprise Plus is a software-defined networking product from VMware. And vSAN is the hyperconverged storage that can be also configured as part of the deployment process. HCX, or Hybrid Cloud Extension, is one of the key products, and that brings the service into a true hybrid cloud model. There are two license editions for HCX, Advanced or Enterprise. We'll be looking at HCX later, and that is the core product that we are going to use for migrating workloads into the OCVS platform. Now, all of these software components are installed on top of bare metal servers within OCI. The bare metal compute configuration holds the capacity for deploying these management appliances along with the workloads. There are compute shapes available in both Intel and AMD processors. For production purposes, there is a minimum of 3 nodes required to be chosen as the vSphere cluster. For non-production purposes, there is a single host provisioning that is available, and usually that is used for testing or evaluation purposes. While VMware vSAN is a storage option in OCVS, there are other storage options provided through OCI. The VMware stack and the workloads can be deployed over an iSCSI-based block storage. There is also NFS-based storage. As an example, you can use the Oracle Linux storage appliance as a file storage. So to wrap up, we looked into the partnership between Oracle and VMware by Broadcom, and that enables you to run an SDDC software-defined data center through Oracle Cloud VMware solution. So that's just a quick introduction about OCVS. Let's now move on to our next lecture. Thank you for watching. Welcome back to this lesson on use cases and key benefits of Oracle Cloud VMware solution. Disaster recovery, or DR, is one of the top use case of OCVS. DR is sometimes referred as business continuity. It is very critical in maintaining a high service quality regardless of any circumstances. There are multiple ways a customer would look at the DR strategy. It could be either adding a new site, or it could be replacing an existing DR. If you run a VMware vSphere environment at the on-premises, you can continue to use the same tools to achieve DR with OCVS. You can choose Fast Connect or IPsec VPN to connect between a production on-premises environment and an OCVS DR site. This connectivity brings both the sites portable for workloads. The next use case is about data center expansion and a hybrid cloud deployment. In most cases, a customer might hit a scenario of running out of capacity. A capacity means it could be a network capacity or a compute capacity or even a physical space in the data center. So capacity expansion becomes a longer term deployment, and OCVS enables the customer to gain on-demand capacity. This would help customers like the virtual desktop providers who could potentially burst the capacity needs. Once the environments are interconnected, you can manage both environments from a single pane of glass window. The next use case is about data center expansion with migration. Data center migration is often triggered by a customer's need to retire an on-premises data center. Again, this would require to interconnect the on-premises and the cloud environments until the migrations are done. There are different ways you can achieve this migration. You could simply do a lift and shift. That means there is no need to refactor the VMs because the source and the destination are the same vSphere platform. Fast Connect is required to facilitate the connectivity and the movement of data, even the quantity of data is in several terabytes. Once all the virtual machines and its data have been migrated into OCVS, the Fast Connect circuit and the customer's on-premises data center can be decommissioned. And in this way, the source data center could be eliminated and an infrastructure refresh could be completed quickly as possible. What are the main reasons to migrate into OCVS? It reduces capital expenditure. You are no longer required to own a data center or purchase any hardware. With using OCVS, you are using the latest hardware and the latest VMware software stack for hosting your apps. OCVS uses an SDDC platform, so you can quickly move the apps without any refactoring. Flexibility and control of OCI could be achieved through OCVS. You can leverage your existing skill sets as you're continuing to use a VMware platform within OCI. OCI gives you enhanced high availability, and that would help you to avoid any single point of failures. Migrating into OCVS provides you cloud native readiness for your apps, and with having hybrid cloud, you could set up a DR strategy for the environment. Let's look into some of the key benefits. Number one is having a dedicated environment with full control. This means you get the full administrative access to do self-services. That includes root access with a full control over your OCVS environment. After provisioning the environment, customers can then own the root credentials, and this gives them the ability to operate the environment, including upgrading or patching the environment. The second benefit is about keeping the same VMware tools. OCVS gives a very familiar experience to a VMware-based on-premises environment. That means you can leverage your existing skill sets for the tools that you're already using it in on-premises. Number three is about seamless migration. The underlying platform of OCVS is the same as the VMS specification, and this would allow you to migrate applications just as it is without refactoring or re-architecting them. With getting your workload footprint into OCI, this gives you access to Oracle's broad portfolio of cloud services, including Autonomous Database, Database as a Service, and Exadata. OCVS is available in every OCI public cloud regions, and so you can choose to deploy it on any commercial OCI regions. Some of the core aspects of Oracle Cloud VMS solution. OCVS has got different pricing interval commitments that you can choose while provisioning an SDDC. It could be hourly or monthly or yearly, 1 year or 3 years. In regards to licensing, VMware components like vSphere, NSXT, vSAN, and HCX are all licensed as part of provisioning the product. It also means bring your own license is not applicable in OCVS. There are 2 capacity types while choosing the bare metal instances for the hypervisor host. By default, you can choose the on-demand capacity for the instances. You can also reserve those instances in advance. That means you can create the instances and then count them against a capacity reservation. Shielded instance is a security feature. It creates a secure boot image for booting up the hypervisor host. These are some of the core values with OCVS. OCVS is a customer managed service. That means Oracle does not hold the root administrative access, and it is completely owned and controlled by the customer. There is an integrated support. There are different tier levels where you can get support from both Oracle and VMware. OCVS offers a zero trust model security. That means a customer can manage their security boundaries without giving any access to Oracle. It is a customer managed environment, so the customer can decide the upgrade and the patch cycles based on their preferences. OCVS is deployed within the customer VCN. That means it gives a much secure connectivity options for your virtual networks. To wrap up, we learned disaster recovery and migrations are some of the core use cases. We referred the key benefits of using the service. We also learned some of the key aspects and value adds of using OCVS. So that's all in this lecture. Let's move on to our next one. Welcome back. We will take a little deeper on SDDC. In this part 1, we will focus on the VMware products that forms together the SDDC platform. Let's start with the hypervisor installed on the bare metal instances. In our previous lesson, we learned about vSphere. It is a distributed software system enabled by the hypervisor software ESXi and a management server, the vCenter. vSphere becomes the virtualization layer for the OCVS SDDC, and that separates virtual machines from the underlying physical hardware. A vSphere cluster is a group of ESXi hypervisor nodes. The vSphere cluster would aggregate resources in a distributed manner. The VMs deployed in a vSphere cluster share resources like the CPU, memory, data store, and network. As an example, the vSphere cluster combines all the physical CPU resources and makes it available for virtual machine consumption. Remember the concept of oversubscription we learned in our earlier lesson? So the same oversubscription would be applied here. There are a few primary features in a vSphere cluster: high availability or HA and distributed resource scheduler or DRS. vSphere HA provides high availability for virtual machines within the cluster. If a physical host fails within the cluster, the VMs residing on that host would be restarted on another host in the same cluster. With vSphere DRS, it is a resource scheduling mechanism, and it balances the overall distribution of VMs within the cluster and depending on the utilization of each host. vMotion is referred as the live migration of a running virtual machine from one host to another host without any downtime. We'll be seeing vMotion as one of the migration method later in this module. In Oracle Cloud VMS solution, there is a minimum number of free hosts required for production purposes. The maximum number of hosts would differ depending on the compute shapes that is used in the cluster. For example, if you're using only dense IO shapes, you can scale up to 64 hosts within the cluster. vSAN is the hyperconverged storage part of the solution. The term hyperconverged means having a high-performance NVMe all-flash drives attached directly to the bare metal compute instances, and that becomes a storage option for storing your VMs. With having a software-defined approach here, you can combine these direct attached devices and create a distributed data store for deploying your VMs. vSAN uses a logical construct called disk groups, and it manages the storage devices into two different tiers, the capacity tier and the cache tier. There would be a set of NVMe drives assigned as the capacity tier and another set of NVMe drives as the cache tier. Capacity tier is used as a persistent storage for the VMs, and it is also used for read cache. The cache tier, it is dedicated for performance-related operations like write buffering. This two-tier design gives much performance to the VMs and also ensuring data is written in the most efficient way. vSAN implements a concept of fault domains, and it is different from the OCI fault domain. vSAN fault domains are about grouping multiple hosts forming into a logical boundary domain. These vSAN fault domains make sure that there are at least two replica copies of storage objects distributed across the domains. Say if an entire domain fails, only one replica would be affected. vSAN storage policies are used to determine the high availability of individual VMs. You can configure different policies to determine the number of host and device failures that a VM can tolerate. FTT stands for total failures to tolerate. And with FTT is equal to 1, this means you can accommodate up to one node failure within the cluster and the VMs can still be functional. FTM stands for failure tolerance method, and with using FTM as RAID 1, this means a replication of an object is always maintained. Witness node is a dedicated host used to monitor the availability of a data object. Now, when we have two replicas of a storage object, as in a RAID 1 fault tolerance method, and during a real failure, it can cause the data object to be active on both vSAN fault domains. This can be disastrous to any application, and so to avoid such condition, we usually call that as a split brain condition, a vSAN witness node is configured. NSXT is similar to the OCI's virtual cloud network. So NSXT is often referred as the overlay network in OCVS. It is heterogeneous. That means NSXT can also be deployed on other hypervisors in an on-premises environment. It can extend features to multi-cloud environments, multiple hypervisors and VMs, containers, and cloud-native application frameworks. You can create virtual firewalls with NSX Edge appliances, use it for load balancing, NAT for VMs inbound and outbound connectivity, VPN tunnels for connecting between environments, and so on. One of the top use cases of being software-defined is automation. There are different REST APIs available for automating operational tasks. It is also compatible with Terraform and OpenStack orchestrations. And with all these capabilities, NSXT becomes very similar to OCI's virtual cloud network. Let's look into some of the components. NSXT works by implementing a few integrated planes: the management plane, the control plane, and the data plane. And all of these are implemented as a set of processes, modules, and agents that resides on three types of nodes: the manager, controller, and the transport nodes. The NSX manager node gives you a graphical user interface. You also have REST APIs for configuring components like the logical switches, logical routers, and firewalls. The controller nodes host the central control plane services and its configuration. Transport nodes are responsible for stateless forwarding of packets based on the control plane. These transport nodes could be the hypervisor host. A transport zone is a container that defines the potential reach of transport nodes. There are multiple types of transport nodes. Transport nodes could be the ESXi physical host, or it could be an NSX edge that has got the forwarding engines implementing together the data plane. There are two types of gateways that you configure for your virtual machine communication. The Tier 0 gateway processes the traffic between the logical and the physical networks. We also call it as the north-south traffic. North-south traffic can also be referred as the communication between the VM and the internet. And then the Tier 1 gateway is used for the east-west traffic. This is the traffic between VM to VM within the same infrastructure. NSXT supports BGP and OSPF. Those are gateway protocols used for VM communication, both external and internal. Segments are simply virtual networks where you connect the VM. There are VLAN-backed segments and overlay-backed segments. A VLAN-backed segment is a layer 2 broadcast domain, and it is implemented as a traditional VLAN in the physical infrastructure. This is similar to a VLAN configured in an on-premises data center. The traffic between two VMs that is attached to the same VLAN-backed segment is carried over a specific VLAN. In an overlay-backed segment, the traffic between two VMs on the same overlay segment are carried through a virtual tunnel between the host. And this is called the network encapsulation with NSXT. But how is this overlay segment configuration possible? Geneve is a network encapsulation protocol, and that creates layer 2 networks with isolated multi-tenanted broadcast domains on top of the VCN. Wrapping up, we learned the core VMware products part of the OCVS SDDC platform, vSphere, vSAN, and NSXT. So that's part 1 of SDDC products overview. Let's now move on to our next lecture. Welcome to the second part of this lesson, SDDC products.